Hi there, welcome to another Force Tech Talk. Today we're going to be talking about counterfeits and how counterfeits affect military and aerospace subsystems.
Hi, Ben. Thank you very much for giving me the opportunity to talk to you. Normally I talk to Karen and to Charlotte, but it's going to be nice to learn something from you today. I want to talk about counterfeit. It's something that for years I would associate it with fake, nice goods or nice t-shirts, like a t-shirt with an upside down crocodile or something like that.
Yeah, that on the
so
market,
that was
yeah.
my understanding about counterfeit, but it's a lot more. Can you explain what is counterfeit? Can you define it on our line of business?
Yeah, so in the semiconductor industry, counterfeits are effectively a remarked or black topped, often you hear that sort of wording, where someone has remarked a semiconductor component with another marking, either to sort of change the speed rating of it, or the temperature rating, or the actual overall qualification level. And it's particularly a concern in the semiconductor market because a lot of semiconductors are made with the same sort of outwards package. You know, a 28-pin dip from one manufacturer looks pretty much the same as a 28-pin dip from another manufacturer. And, you know, when you get into the plastic components as well, the packages look almost identical in, you know, the sort of, 28-pin SOIC or a 32-pin or plastic dip is very much the same across manufacturers. It's very difficult to sort of tell them apart, especially since they're made to industry standard. You know, the JEDEC overall sort of dimensions of the package ends up being identical. So it's quite easy for a counterfeiter to, you know, sort of remove the existing mark and then put another mark on top of it and then sell it as either, you know, a different component that maybe a customer needs, or a more expensive version of that component. And unless you've got some sort of advanced detection methods, then you're not gonna pick that up before it gets onto a board and it starts causing problems on the board.
So for an untrained set of eyes like mine, it would be really hard. What are the potential segments we should explore when dealing with counterfeit?
Do you sort of mean by the actual sort of testings that you should be doing to them? Well, I mean, mercifully, there's some quite strong industry guidelines that a lot of companies follow nowadays. It sort of started with the AS9100. Sorry, AS6081, and then moved on to AS6171. Yeah. And they document quite heavily what those components, you know, what testing needs to go through on those components. So you do things like visual and dimensional checks to the original sort of drawing, you know, making sure that all the thickness of the component and everything else, and the width and height and length of the component is all accurate. That's obviously quite surface layer. You know, then you go on to sort of doing chemical testing on the top of the component, because one of the key ways that counterfeiter will counterfeit a chip is black topping, as mentioned earlier. So they'll sort of layer over a sort of epoxy layer over the top of the component that is quite resistant to sort of standard chemicals that you'd use to remove it, and gives the impression that it's, you know, even if you look at it under a sort of high magnification, it's often quite hard to tell the difference between that top layer and the actual sort of plastic as well. So you have to use some quite strong acids to try and remove the top of that black top material. You can also heavily X-ray the component. Standard also calls out for that, which allows you to sort of look at the uniformity across a batch, checking the internal lead frame and the structure and, you know, the die size, etc. Then you also take a small amount of the components, you know, 3 pieces, and decap them. So that means effectively removing either the lid of the component or the encapsulant material to actually physically look at the die. And then, you know, most OEM dies have a logo or some kind of marking, which relates to the part number. So that's another authentication method. And the standards obviously call out, so AS6081, a lot of companies never used to do electrical testing. So a lot of customers used to do AS6081A, which was mainly a physical dimension verification.
Or check paperwork as well.
Yeah, check paperwork. Check, do your X-rays, do your decaps. Make sure there's no sort of outward sign on the component that there's nothing been tampered with on the component. But then then some customers and suppliers would add electrical testing as well. We always defined electrical testing, but the AS6171, even at sort of the moderate levels, now includes pretty heavy electrical testing as well, either DC and or a combination between DC and AC. So you sort of you're all round checking the component to a really high level of certainty that there's there's nothing wrong with it.
And what defines where or how far you want to go with the test? Is there a level of risk? How do we get there?
Yeah, so the AS6171 specification defines risk inherently within it. It's obviously up to the customers to decide for their application what risk level they should go to. Okay. Most of the industry uses the moderate risk level 2, I believe it is, which is effectively AS6081A with all the additional electricals on it as well. But yeah, it's really they have the AS6171 standard starts with a low risk, moderate risk, and then high risk, and moves right the way through. So you can really scale up the amount of testing that you do. And on the highest risk end, you're doing infant mortality testing through burn-in and lots of other destructive testing on the batch to make sure that it's going to be good for a critical application like a aerospace application or something similar.
Yeah, I believe if we have the misfortune of getting counterfeit getting in the system and the supplier chain, the risks could be really bad for the systems we work with. If it goes to an airplane, it could be dangerous for the airplane. So I think for any actor inside this chain, the ethical behavior is important.
Yeah,
thing to consider as well.
Yeah, very much so. Yeah, I mean that's why we have approved suppliers. That's why we go through such rigorous checking for approved suppliers. I've been at Force now 20 years, and I can't remember the last time that we had what I would call a actual counterfeit device. You sometimes buy product in and it's the leads are heavily oxidized, or maybe a dimension's ever so slightly out, and those kind of things often are a result of not a counterfeit, just a poor manufacturer's documentation or things like that. So it gets flagged as something along those lines. Deviation. But then it's then you have to ultimately look at, well, is that something that's a true indication? The most true indication you ever see of a counterfeit component is generally that you see sanding marks, or somewhere where they've literally gone in and sanded the top of the component off, removed material, placed a new material on it, and marked it over. But yeah, mercifully that's very rare. But there has been a huge uptick in counterfeit components reported by the industry. So
yeah, I heard a lot. I think figures around 25% of what gets into the market at the moment.
Yeah, I think it was 25% between 24 and 2025 when comparing back to 2015. So it's a substantial uptick in counterfeit components that are being reported. So
it's really important to invest on prevention before it gets a bigger problem and we have it's inside the system, inside the supplier chain.
Yeah, I think most of the industry is now working quite well to those standards, and they've been adopted widely by the aerospace and defense market, certainly.
Definitely, it's not a wasted money. Actually, it's a good inversion.
No, a lot of sort of distributors, when they're working in quite tight margins, $1,200 for an authentication test or something like that can seem expensive, but it's well worth it.
Yeah, I think the time we have is finished. Thank you very much for explaining a little more about counterfeit and for sharing your knowledge.